Hello and welcome back to our channel. Today we'll be working on question 12 from the 2005 STEP paper 1. This is from part C, probability and statistics. So let's get started. Question 12. The probability that a hobbit smokes a pipe is 0.7 and the probability that a hobbit wears a hat is 0.4. The probability that a hobbit smokes a pipe but does not wear a hat is p. Determine the range of values of p consistent with this information. Part B. The probability that a wizard wears a hat is 0.7. The probability that a wizard wears a cloak is 0.8, and the probability that a wizard wears a ring is 0.4. The probability that a wizard does not wear a hat, does not wear a cloak, and does not wear a ring is 0.05. The probability that a wizard wears a hat, a cloak, and also a ring is 0.1. Determine the probability that a wizard wears exactly 2 of a hat, a cloak, and a ring. The probability that a wizard wears a hat but not a ring, given that he wears a cloak, is q. Determine the range of values of q consistent with this information. Pause the video to have a go at this solution, and once you're ready, restart to see if you're right. In order to complete part A, I'll be drawing 2 Venn diagrams to show the 2 most extreme cases. The first case, on the left here, is that all hobbits who smoke a pipe wear a hat, and in this case, the region that we want is 0.3. The second case, on the right, is the case where the overlap is smallest. In this case, the number of hobbits who smoke but don't wear a hat is 0.6. Therefore, we have the range of p as between 0.3 and 0.6 inclusive. Now let's move on to part B. Now, we'll let x be the probability that a wizard wears a cloak and a hat, but not a ring. Y be the probability that a wizard wears a hat and a ring, but not a cloak. And z be the probability that a wizard wears a ring and a cloak, but not a hat. Now, we'll let a be the probability that a wizard wears a hat only. That is 0.6 minus x minus y. B shall be the probability that a wizard wears a cloak only. That is 0.7 minus x minus z. C shall be the probability that a wizard wears a ring only. That's 0.3 minus y minus z. Note that A, B, and C can't be negative. We'll now notice that 0.1 plus 0.5 plus A plus B plus C plus x plus y plus z equals 1. X plus y plus z therefore equals 0.75, which is the probability that a wizard is wearing exactly 2 items. Now for the last section of this part. Given C, the probability that a wizard wears a hat but not a ring is q, which we shall write as x over 0.8. Now, let x equal 0.6 minus k. This will help us calculate x. The probability that a wizard is wearing a hat only is k minus y, and the probability that a wizard is wearing a cloak only is k minus z plus 0.1. Neither of these numbers may be negative. Now, 0.5 equals k minus y plus 0.6 minus k plus k minus z plus 0.1 plus 0.1 plus y plus z plus 0.3 minus y minus z. This simplifies to 0.95 equals 1.1 plus k minus y plus z. K equals y plus z minus 0.5. Now, since k minus y is greater than 0, we have z is greater than 0.15. Similarly, due to k minus z plus 0.1 being greater than 0, y is greater than or equal to 0.05. 0.2 is less than or equal to y plus z, which is less than 0.3. This means that k is between 0.05 and 0.15 inclusive, meaning x is between 0.45 and 0.55 inclusive. This means that q is between 9 over 16 and 11 over 16 inclusive, and that's the question solved. Thank you for watching. If you liked our video, please like and subscribe, and we'll see you next time.